welcome to Section 2 Midterm Review. Okay, we'll get started with number 1. And in this case, number 1, we have a system of equations. We have really only one option here, and this option would be to go ahead and solve one of these equations for x or y. And this first one is, and now we can sub in what y is equal to, and y is equal to x squared plus 6x plus 9, right into the other equation for y. So we'll get x squared minus 6x plus 9, and then we have the plus x equals 5 of the other equation. We have a quadratic equation. We're going to bring everything over to the left side. We're going to set equal to 0. So we have x squared, we have a minus 6x and a plus x, which is minus 5x. We have a 9 minus 5, which is positive 4, and that's equal to 0. So we will factor x minus 1 and x minus 4. We will do a t-chart and get x equals 1 and x equals 4. These are the x coordinates of our 2 points of intersection, 1 and 4. And we can plug both the x equals 1 and x equals 4 into either of the original equations, for instance this equation, to get our y equals 4 for this one, and then y equals 1 for this one. So there are the two answers. Next question here, number 2. Let's see, can we do this? Alright, let's zoom out here. Put that up over there. Number 2. So number 2 is asking another system of equations. What I'll do is, it's only asking for the x coordinates. So in this case, they're both solved for x, they're both solved for y. So we can set them equal to each other. In our case, we get 3x minus 6 equals x squared minus x minus 6. And if we bring everything over to the right side, we will end up getting 0 equals x squared minus 4x. We can factor by taking out a greatest common factor, and then we can go and do a t-chart. We'll get x equals 0 and x equals 4, which in this case is just choice 2. We have some graphs in number 3. Alright, so number 3, we have a couple graphs. We need to be able to determine from a graph what the roots look like. So we have 3 graphs here we'll take a look at. The first graph will intersect the x-axis in 2 points. The next one will just touch in 1 point, and the last one will not touch at all. The x-axis is called the real axis. So this is real, and that means if the graph of the function crosses the x-axis, it has at least one real root. In this case, it crosses in 2, so these are 2 real roots. Okay. There are 2, so they're not equal. We call them unequal. We don't know if they're rational or irrational by just the graph. The next one here, you have only 1. Well, it does touch the x-axis, so it's real, but we're going to call this equal. There's sort of 2 roots, but they're the same. They're equal. So this is considered one root here. And if the graph never touches the x-axis, we call these roots or solutions complex or imaginary, and there are always 2 of them. Okay, so that's number 3. All right, so number 4 gives us a quadratic equation, which we will set equal to 0, so we can take a look at it. It is 3x squared plus x minus 14 equals 0. We could go ahead and solve this equation, but the question is only asking for the what we call the nature of the roots, or the description of the roots. A quick way to do this is just to take a look at the discriminant, which is simply b squared minus 4ac. It doesn't include the radical. So we're going to just take a, b, and c here to be 3, 1, and negative 14. We're going to plug them in to our b squared minus 4ac. We're going to plug the whole thing into the calculator. So the b is 1, A is 3, and this is negative 14. So this number that we get should be 169, which is a positive number. So it means it's going to look somewhat like this first one up here. So there will be two real roots that are unequal. Since this number here, the discriminant 169, is a perfect square, the roots will be rational. So here we have rational, real, and unequal roots. If the discriminant here was a non-perfect square, like 165, we would have irrational, real, and unequal roots. So this would just be choice 3. Slide here. Number 5 was the same question as we had seen before. Number 6 is another completing the square problem. So just a quick look, completing the square. It just allows us to solve a quadratic equation, and we'll always bring the constant over to the right at the beginning. We will get x squared minus 6x. We're going to be completing the square by adding a number, and we will add that same number to the right. The number we add is going to be this number, which is your b term, negative 6, divided by 2, which is negative 3, squared, and that gives us a 9. 9 goes in as added to both sides, and that allows us to factor the left side to be 2 of the same factor, so we can write it as squared. You have x, and then you take half of that number there, that b, which is negative 3. And on the right side is 34. Now we would continue to solve for x, in this case, by taking the square root of both sides, leaving us plus or minus, we're at 34 on the right, and we get an x minus 3, and then we simply add 3 to both sides to end up solving for x. 3 plus or minus radical 34. Rad 34 doesn't break down, so we just keep it as that. Okay, so in number 7, we're just really just writing the vertex here. And the vertex, we get the x coordinate of the vertex when the equation is in this form by taking the opposite of what we have in the parentheses. So in this case it's 8, and it will be the same outside 3. So the vertex is 8, comma 3. And the vertex in B is just going to be negative 2, negative 5. Opposite inside the parentheses, same outside the parentheses. Now in number 8, we're asked a question about, or we're told that we have a polynomial, and we're asked if 3 is the root. Now if 3 is a root, if we do plug in 3 for x, we will get 0. So that's what we're going to do. We're going to take x cubed minus 3x squared minus 2x plus 6. And to see if this is a root, this 3, we will plug in for x the possible root, which we have here to be 3. And if this gives us 0, if it gives us 0, we're not sure, then it is a root. If it doesn't give us 0, it's not a root. This is called the remainder theorem. So in our case here, we end up getting 0 on the left-hand side, and that means that 3 is a root. So 3 is a root. 3. Okay, so next question, and number 9, it's asking us again about a root. So you can try all of these here, but number 9, what you could do is you can go into the calculator, type in y1 equals 4x cubed minus 3x squared minus 25x minus 6. And in your table, where you have x and a y, basically the calculator will plug in all these different options for x here. Now, it won't have a quarter. You can plug that in yourself here. But it does plug in 2, and what it comes out with is what we have in the y. And you'll notice that for it to be a root, we want 0. And in this case, if we plug in x equals 3, we do get a 0 for the y. And that means that choice 3 is the answer. You could plug in 3 as well, just like we did in the last problem, and you'd get 0 as well. 10 and 11 are just some quick questions, very similar. But in this case, we have factors. So I don't want to divide this all right now. And as long as I'm asked for the remainder, I can simply and this is divided by x plus 2, I can simply take the opposite in the parentheses, which would be negative 2. I'm going to plug that in for x, okay, and I will see if I do end up with a 0, then I know that x plus 2 is a factor. If it doesn't equal 0, then x plus 2 is not a factor. But we want you to write that. In this case, I'm going to end up getting 5 here. And that means that's the remainder. All right? And if there's a remainder, it means that x plus 2 is not a factor. Remainder, so x plus 2 is not a factor. All right? And number 11 here will be a very similar problem. Number 11, you can just plug it in, and you will get 4 times 1 cubed minus 9 times 1 squared plus 9 times 1 plus 3. And that, I believe, will give you 12, 16, that gives you 7. And 7 is the remainder. So in this case, therefore, since remainder doesn't equal 0, in this case, n minus 1 is not a factor. Okay? So you want to write something like sums up what you actually found out. All right, we're back. We skipped number 12. We didn't like that one. So we're on number 13. And number 13, it should read, is x plus 3 a factor? And in this case, you're plugging in a 3. We're plugging in a minus 3. All right? We're plugging in a minus 3. And we're going to see what we get. In this case, we'll get 18 minus 15 minus 3. So in this case, we get 0. So that 0 means, that's a remainder, it means that yes, and I'll be brief here, but x plus 3 is a factor. Likewise, in number 14, it should read x minus 5 here. Make sure you have the x minus 5. And that means if we plug in an x equals 5 into our 3x squared minus 13x minus 10, again we're plugging in a 5 because the factor was x minus 5, we do get the same 0 here, which is the remainder, and that means that x minus 5 is a factor. Check. Here we go. Number 15. All right, so for number 15, we're back to the trig. This is just your QRS. And exact value means we're going from the chart. So sine of 330, that's a QRS. And that would be the fourth quadrant. Reference angle is 60 degrees. Sine is negative in the fourth, and that would be negative rad 3 over 2. But clearly I did not do that right, and I'm rushing. So that this reference angle here is actually going to be 30. And then this would be 30. Thus, our answer is negative a half. Now, what I would do if I were checking my work here is I'd type in the sine of 330. That actually would just give you the negative a half in the calculator. So I would make sure that my answer does match that one. Okay. For B, it's QRS. You end up getting 1. And for C, the QRS, you end up getting negative cosine of 60. And in this case, this is negative a half as well. All right, so we're trying to conserve our time and space on the computer here. So number 16 is a breakdown of a radical here, and this is something that some people have still have some trouble with. So what we're going to do is we're going to make sure we break this up into 2 different groups. One is the perfect squares, and the other one is the non-perfect squares. So we look at 192. We know that's not a perfect square. And we go to the calculator, we take y equals 192 divided by x, and in our table, we're going to go to where we see error in the y column. That's where x is 0. We go down from error and find our first perfect square. We happen to notice that it's 64, and that means, and in the x column here, 64 would be 3. So 64 is perfect, 3 is not. We do the same thing here. The variable will be perfect. when it is a multiple of the index. And this square root, it's 2. So 4 is a multiple of 2, so that's perfect. But y cubed is not. So we bring down that to the squared, keep a y in there. Z to the 5th, 5 is not a multiple of 2, so z to the 4th is, and z would be here. Square root of 64 is 8. X to the 4th, the square root of x to the 4th, is this 4 divided by this 2, or x squared. It'd be y and z squared, radical 3yz. Okay, so that is 16a. 16b, okay, so 16b, what we have is we have a cube root. So you need to notice that you are dealing with a cube root. So the process is the same, but we're looking for different things. So this is a squared b cubed, c to the 6th. And again, 2 radicals here. We have cube roots. And the cube root, again, you're going to have y equals 135 divided by x. Right? And you have x and a y. You go to where you see the arrow there. And you look for your first perfect cube, and that happens to be 27. And in the x column, that would be a 5. All right. So 5 is this perfect is the 27, perfect cube. 5 is not. Now we're looking for multiples of 3 to be perfect. Well, a squared doesn't even get to the 3, so that's not. B cubed, 3 is a multiple of 3, and 6 is a multiple of 3. So cube root of 27 is 3. You divide the 3 by the 3 and get b to the 1st, or just b, and this would be c to the 6th divided by 3, or squared. Don't forget your cube root. We have 5a squared. All right. So I'm going to stop here. 17, I'll just list the answers there. That's just a tabular there. I think you'll be all right. It's A, and that B should give us 12x to the 4th. Again, tabular is the way to go. 4x cubed plus 53x squared minus 3x plus 33. Okay? Have a good one.